Yeah, so today we will look at the dynamic memory allocation in today's class and in the next couple of classes. Um so yeah, so what we will do is the problem at hand before us is we would like to, given a list of names, we would like to sort that names. So that is the problem. So given a list of names, we would like to sort those names. Is there any command for the same, for to sort a list of names? Yes, I think there's a sort command. I'm looking for a command. So like for example, if you have, so I have this file names.txt, for example, which contains names of different names. Uh, so sort is a Unix command, and if we give to sort this names.txt, it sorts the names, it prints the names in the sorted order. And you can see, like Anirudh is coming 3 times, Binod is coming 3 times, etc. Because Anirudh, for example, is occurring here in the unsorted file. It is here, here, and here. So uh, yeah, so this is how sorting the what sort does. So this, and our goal is to design this program. So given a list of names uh, in a file, so given a list of names in a file, we would like to sort the names and print them in a sorted order, right? So if you look at man sort, so you will give some yeah, so if you want to do sort the names in the opposite order, I think if we had to use sort minus r. So if you use sort with minus r option, then it will print the names in the opposite order. And then let's see what other options sort has. Yeah, and if you want to write it to a different file, so sort names minus o names dot sorted dot text, and then if you look at names dot sorted dot text, you will see the names are sorted in a or they're in the sorted order. It is just printing, it doesn't change the names in the file. So we have to write, our goal now is to write this sort program is available in on your Unix, on all Unix systems. So Linux, even Mac also, I guess should have this sort command. All right. So now we have to write code to uh, to, to solve this sort problem. So now let's see. So I have this code. So this is so when I'm teaching when while discussing this topic with section A, so we started from the scratch and wrote the code together. And but in any case, here now we have the whole code. So we will just go through the code carefully. So as you can see, the first thing is, so given any problem, what is the first question that we should be asking? Given any problem, what is the first question we should be asking? How to store data, data representation. Excellent, guys. So you are spot on. So that is the most important thing that we need to uh, design or make a decision on. So in this particular program, we decided to store the names as in a two-dimensional array. So in a 2D array. So we have a 2D array names. We have a 2D array names. So the number of rows, this is the 0th row. This is the first row, so on and so forth. The number of rows is equal to max underscore list. The number of rows is equal to max underscore list. And every row, in every row we store a name. Like for example, maybe like we can say, so Venu. And then we have the null character. So like that, every row we will store a name, and we have to, and the maximum, so the number of columns here is given by max underscore name underscore length. So let's say if max underscore name underscore length, if it's a macro, if it is equal to 20, then what does it mean? So based on this, so here if you go up, you can see that max underscore list is 100, max underscore name underscore length is equal to 20. So based on this, this is equal to 100 and this is equal to 20. Based on this, what can you say about the kind of data which this program can handle? So what can you say? Yeah, so the maximum number of names that you can handle is only 100, and the length of each name has to be less than 19 characters. Has to be less than 19 characters, because when we are storing a name as a string, it has to, we should conclude it or end or terminate it with a null character. So if the actual number of characters in the name is 4, for example, like in Venu, we need one more space, one more byte to store the null character. So the maximum name length we can handle is 19 characters, and the maximum number of names that we can store in our program is 100 names. Are you all fine with this representation? Do you understand this data representation? Any questions? As we keep going, this gets more and more complicated. So you should all with me. And where will the memory for this 2D array names is allocated? Where will be the memory for this 2D array names is allocated? Yes, not in the data section, Siddiq. No, it is in the stack, and specifically, as Balaram mentioned, under the activation record of main function. It's on the stack. And how many bytes are allocated to this names array? 2000 bytes. Excellent. Very good. So now if you see the structure of the program, on line number 56, we are, so we call a function called read names, and to this read names we pass names as the parameter. So when we pass names as the parameter, what is it that we are actually passing to the read names function? Yeah, the base address of this 2D array. Exactly. The base address of the 2D array, not 0, comma 0, address of 0, comma 0. That's true. Yeah. So the base address, remember this 2D array, it gets flattened out in the memory. In the main memory, it gets flattened out. This is your main memory. Your main memory is in a row major fashion. So your main memory is a series of bytes. So this 2D array is flattened out using a row major fashion. And the base address of the 2D array is passed as parameter to the read names function. Since the read names function knows the base address of this 2D array, it is possible for it to go and change the contents of these memory locations. So essentially what this read names function will do is it reads the names from the keyboard and it returns a value. That value is the number of names it has read. So the number of names it has read is stored in a variable called NO names on line number 56. So remember, base address of an array is always by default, it's a pointer. Names is a pointer by default. It contains the base address of the array. Names by an array by default is a pointer because it contains the base address of the array. And on line number 57, we call a function print names, which takes names and the number of names and it prints it. And then we call a function on line number 59, sort names. And then finally on line number 63, we print the sorted list again. So you can see that the names are, after the names are sorted, no, they occupy the same array. They are not copied into some other array. So they are sorted in place. They are sorted in place. So because of that, we just have to print the same array, and we will see that the list is sorted. All right. Are you all with me on the structure of the program? So there are three functions that we have to study. The first function is the read names function, how the read names function works. The second function is the sort names function, which is the actual code for sorting the array of these strings, this list of strings. And finally, the print names function. In terms of complexity of these three functions, the print names function is the simplest. And yeah, so maybe after that, read names function is a simpler one, and then the sort names function. So we will start with the read names function and see how it works. So yes, again, I just want to point you out. So we are using this macro max underscore list and these two macros. We are defining these macros and we are using these macros in the whole program. Like for example, here we are not declaring a variable length arrays here because max underscore list is expanded to 100 because it's a macro, and max underscore name underscore length is expanded to 20 because again it's a macro. So now let's take a look at the read names function. So the first important observation is look at the function signature. The function, it takes a 2D array, the base address of a 2D array is a parameter. And it returns an integer. The value it returns is the number of names it has read. So remember, when we are passing a 2D array as a parameter, so the particular signature that we have to use is like this. The first parameter, so in the first square bracket, it will be empty, but the second square bracket should contain the length the no, the number of the second dimension of the 2D array. Like for example, here the length of the along the second dimension, the number of columns in our 2D array is 20. So that we have to mention here. We discussed this, you all remember this, right? Why this is required also, we have discussed this few classes back. Are you all with me here on this? Why we are passing, why we are declaring this function signature in this particular form. So this is what we do. Great. And then, so we are keeping track of the number of names successfully read using the variable I. I'm not sure, Gautam, whether we can fill the first dimension in 2D array. I don't think you can do it. When we are passing a 1D array, we just pass only one empty square. We will have just only one empty square bracket. When we are passing a 2D array, the first square bracket will be empty, but the second square bracket, yeah, this should always be empty. No, we cannot write that, Mayank. So the first square bracket should be empty, and the second square bracket, it should contain the dimension, in this particular case 20. So that dimension we have to enter here. The reason we have seen, oh, for scanf, okay, okay. Understood, Mayank. Okay. So here what we are doing is, so we have, so initially the number of names that we have read is equal to 0. So I is equal to 0. And so we are doing a scanf percentage. And the first name that we would like to, or the 0th name that we would like to read, we want to store it in the 0th row, and the base address of the 0th row is no, the base address of the 0th row is this. And it so turns out it's, even if you don't give this second thing, it seems it will work. But for me, I would like to use this for the clarity's sake, because my logic, I want to explain, because this is the, if you go to the basics, this is what it means. Because if you see, this is if you see this thing, so this is names of 00, and you know, and this is names of 10. And then here, this is, if you keep going like this, if you consider the ith row, this is names of I0. And whenever you want to read a string or anything, using scanf, you need to pass the base address of the memory location. So the base address in the case of the string, if you want to read it to the ith memory location, the base address is nothing but the address of names of I0. So there is some discussion going on equal to. Please, for the time being, hold on the discussion. So I will take it again. But are you all with me on why we are using the address of names of I0? Because we want to pass the address to the scanf function, telling whatever the string that you read, you kind of copy it starting from this address. You kind of copy it from this address. So this address, we are passing it to the scanf function. But so it so turns out, even if you don't give this, C kind of optimized this, I guess. So even if you don't give square bracket 0 here, it will still work. But for me, this is a very clear thing on what is happening in my code. So because of that, I would like to use it this way. And what will scanf return? Scanf returns the number of values it successfully read, the number of input things that it successfully read. So whenever it reads a string successfully, it returns 1. And when it encounters end of file, it returns -1 or end of file symbol, in which case we come out of this scanf function. So if you want to check, initially, if you don't give any name, if you just hit a end of file symbol, you don't enter into the while loop, and you just have, you return I is equal to 0, indicating this ampersand means the address, Anurag. So if you just use names of 10 or names of I0, then it is the value that is presented at memory location. But if you use ampersand, then it is the address of that location. Because of that, we have to use this address. Because for scanf, we need to give to scanf the address of the memory location. So you come on after you read a name, you you increment I is equal to I plus 1, and you check if it is equal to max list. That is here the array that is that we are trying to fill in, it is already full. We have to press enter. I'll run this program and show you. And then after the end of file symbol is encountered, you come out of this loop because of two reasons. One is you have already read 100 names, in which case you come out of this loop, or you pressed an end of file symbol, and so you are out of this loop. So that is how the read names function will work. Are you all with me on the read names function? And if you see the print names function, the print names function is extremely simple. So again, you pass to the print names function the base address of the array and the number of names. And then you have a simple for loop which prints each of the strings, each of the rows. So you just write a loop for I is equal to 0, I less than the number of names, plus I, and then you use a printf. So this is how the read names and the print names function works. All right. So in order to, so how do you print a string? So you give for printf also, you give the base address of the string, because printf needs to know the base address, because it keeps incrementing the character pointer until it hits the null string, null symbol. On the contrary, if you just give this, what will be passed is the character that is present at names of I0. It doesn't work. So for printf, when you are doing %s, you need to give the base address of the string. So because of that, we again need this ampersand here. Because no, names of I doesn't work, Gautam. No, that is an optimization way. No? If you remove 0 also, C implicitly assumes that. That's not the point. Just using names of I, yeah? So just by using names of I like this. Yeah, I think maybe C could be using some like this. Okay. All right then. So maybe C is using, we just have to look at the semantics of C a bit carefully. But yeah, so, so but anyway, but you understood the point, the reason why I am giving this, right? In this particular approach, I am just kind of taking a very fundamental approach here because I just want to give the base address of the string that we would like to print. That's all. I didn't get you, Mukund. You mean names of I, right? Here, while reading. Let's see, Ananya raised the hand. Let me check. 1 minute, Ananya. Okay. All right then. So I think you are. That's true, but names contain the base address. No? The names when we are calling read names or print names, names contains the base address. But the my my thought process is when we use okay. Anyway, I think yeah. So I see the point you are making. So if you use names of um I just have to check the C what the C language says about this, whether it gives the address of names of zero, but it looks like the case. But yeah, it's okay. Yeah, I see what all of you are saying. But I also want you to see names of I is a pointer to the ith row and zeroth column. That's what Ayush is saying. Okay, that is great. Anyway, so good. Uh, so now in the sort names function, this is the sort names function. This is a so this again takes the base address of the 2D array and the number of names, and this is a bubble sort function. So in the bubble sort, like what we do is we use a 2D loop. So there is an outer loop and the inner loop. In the outer loop, so using the outer loop, you bubble up the largest elements. Like for example, here, if you have, if I just take integers, or let's say if I take, this. This is 2D array of strings. This is 2D array of strings, right? Uh, so in the bubble sort, so what we are doing is, so you compare this string with this string, and if this string is, like for example, yeah. So what we have, uh, you have here Venu is there, and we have Satish is there, and you compare Venu with Satish, and Venu is larger than Satish, occurs lexicographically later than Satish, so we do a swap. And then, so after this swap, the state of the array, it changes like this. So now I'm just erasing it, and maybe I will write it like this. So here, so we will have Satish, and here we will have Venu. This is what happens. You swap. And now what you do is you compare Venu with 4 is present here. And let's say here, so yeah, no, our nice jowl is sitting here. So you compare Venu with Giaul. So Giaul occurs lexicographically later than Venu, so there is no swap happens. So here there is a swap, so here there is no swap. And now you continue this process. So you compare Giaul with the next person, and with high probability, the next person may not start, his name may not start with Z. So Jia will get swapped to this position, and you keep on doing that. So finally, Jia will end up here through a series of swaps. So you bubble up Jia all the way till this place. And that is what happens in the outer loop. So in the first iteration of the outer loop, when I is equal to 0, you bubble up the largest person to the last position. And then when I is equal to 1, what you try to do is you consider the rest of the structure, and again you repeat the same process. And that's why we have this minus I is there. Minus I. When I is equal to 1, so instead of you consider starting from here to here, and we keep doing like this. So one important thing that we have to understand here is when you compare Venu and Satish, and so what happens is so if Venu is less than greater than Satish, you want to swap, right? and this is the swap function we are writing. So here we are using string compare function to compare the jth and j plus 1th names, which are consecutive to each other. And if the jth name is smaller than the j plus 1th name, then we are swapping. What does this mean? This particular thing means if the jth name is smaller than the j plus 1th name, then we are swapping. Then does it mean we are doing an ascending order or a descending order? Ascending. Huh? If the jth name is smaller than the j plus 1th name, we are swapping. So what will happen if when we compare Venu with Satish? When we compare Venu with Satish, so let's say this is Venu, this is Satish. What will happen when you compare Venu with Satish? Swap doesn't happen. Yeah, so Venu occurs later. So the value returned by the string compare will be greater than 0 because Venu occurs later than Satish. So because of that, swap that doesn't happen. So the way we are doing it is we are bubbling the smallest element. So because of that, we are ordering the names in the descending order. We are bubbling the smallest element, not the largest element. So string compare, it's a simple function. So uh, we will see. First, are you with me on this one? We look at the string compare in a moment. But are you all with me on this function? And do you see how this swap is working? To the swap, we are passing the base address of the two rows, and you copy one string to a temporary string, and this is how we swap two numbers. The way we swap two numbers, similarly, we are swapping two strings. So in order to do a swap of two strings, we are I will talk about the bool thing once, but do you understand how the swap is working? So in order to swap two, like for example, if you would like to swap Satish and Venu, you pass the base address of Satish and you pass the base address of Venu, and you copy Satish into some temporary buffer space, and then you copy Venu into the upper uh, here. So here, so let's say we would like to uh, swap Venu on Satish. If you would like to swap Venu on Satish, you are doing a string copy of Satish into some temp buffer. This temp buffer contains Satish, and then you copy Venu into the location of Satish, and then you copy Satish from the temp buffer back to the place Venu is present. This is how the swap of the two strings is happening. Are you with me here again on this, how we are swapping two strings? Uh, I think I just used it to account for the null character, but I don't think it's necessary because yeah. Slash n, I don't think it is in the string. I don't think so. Slash 0 is. Null character is in the string. All right. So, and why are we using any swap? That variable any swap? Yeah. So Essentially, that so this any swap, what it does is it keeps track of the fact, yeah, to reduce the maximum number of possible iterations. Let's say if you are trying to sort an already sorted list, so you compare 10 and 20, so no, there is no swap happens, and then you compare 20 and 30, there is no swap happens. So if there are no swaps at all, then that means the no the list is already sorted, in which case you come out. But on the contrary, if the list is something like maybe 40, 10, and 30, then you compare these two. So there is a swap. This becomes 10, 40, 30, and then you compare these two. So you have 10, 30, and 40. So what happens is, in this particular case, you bubbled up the largest 40, and then you go and again work here. And if the rest of the array is already sorted, then there will not be any swaps, in which case you can conclude the sorting procedure. So it reduces the time complexity of the algorithm. That's the reason for the any swap function. So Mayank, don't worry about the time limit errors. I will tell the TAs not to. Yeah, that's true. If any swap is false, it means the rest of the list is sorted. What happens, Siddiq, if you kind of see, you start with a list of numbers or names, and after the first iteration, so what happens is the largest element settles down here. If you are sorting it in a ascending order, and then again after the next iteration, the largest two elements, no, they settle down here. So what happens is after the largest list settle downs here, and when you try to sort the rest of the list, and if this list is already sorted, then any swap turns out to be false, because you don't do any swaps because they are already in the right order. In which case you don't need to go here. It's not necessary. You don't need to go to the next step. That's what it is. Does it make sense? Okay. All right then. Yeah, that's all we have here. And what do we do? So let's compile this program and see GCC name sort. So you can see here we are printing. Yeah. So let me the sorted names, sorted list. Rama, Krishna, Judith. Not sorted. Huh? Yeah, it's not sorted. Huh? That's what I'm thinking. Ha 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 ha. That's true. That's true. But everything is there. If you leave Zach, then or is the list sorted? No, no, yes, yes, no. That's true. It is sorted. If you leave Jack aside, it is sorted. Yeah, it is sorted. Yeah, in a descending order. So in order to make our life easy, let me make this greater than 0. String compare, and I don't want to print the names, just sort. Yeah. Let's use the same. Huh. Nice. Yeah. So now it is printing. So again, what did I do in the printing? I put the slash n here. That's the problem. Okay, good. All right then. So this is about the, yeah, we can use two upper while storing. Yeah, we can use two upper. Good idea. So yeah, now, so Sukinder asked, how does string compare work? Do you think, can you write a function for string compare? This is the homework problem I want you to know. If I say no programming problem of the day, why don't you should be able to write string compare by yourself. You should be able to write. So this would be like, for example, no, if I give it in the, if I give that problem in the exam, like write code for string compare, you should be able to do that. So it's in, you should, we did it already. I forgot, maybe, yeah. Yeah, of course, no, it's a string compare. When you call string compare, some code gets executed, so it has its own time complexity. So Parshva, I would like you to think about bubble sort and why that swap thing works, variable works. And I will send this code, so I want you to think about it. Okay, so there is some explanation I have given at some high level, but I would like you to think and see exactly what is happening. It's not too hard, so think about it. Okay, that's a homework for you. So now moving on, what is the problem with this code? So are you happy about this code? We wrote the code. It seems to be working. Tell me, are you completely happy with this code? So Vaibhav, don't worry about time limit error, because in the final exam, I will be telling the TAs not to worry. There will not be no time limits. So good question. So Mayank is asking, so how dynamic memory, this class is about dynamic memory allocation. So how is it used? So yeah, we didn't use it yet. So the with respect to the problems, Balaram pointed out to the right thing. So we are limited to only 100 names. That's an issue, right? What else is a problem? 100 names is a problem. What else? And the size of each name is bound to 20 characters. So these are the two problems that we would like to solve. So in order to solve this problem, like wasting memory. Yeah. Yeah. So there are Shreyansh and Venu has 2 points that, there could be lot of wastage of memory. If we are storing less than 100 names, then we are wasting memory. And when we consider names, some names could be of 5 characters length, some names could be of 10 characters length, some names could be of 18 characters length, so on and so forth. So that's an issue. So that's an issue. So there is a wastage of memory. And at the same time, like there are so these are the issues. Okay, so we cannot handle more than 100 names. We cannot handle names whose length is greater than 20. And no, so if we go aggressive and increase the max underscore list size to million, then we will be wasting lot of memory. Similarly, if you change the max underscore name underscore length to, let's say, to 200, then again we will be wasting lot of memory. We can ask the user to enter the limit, but still, no, the user may also not be completely sure about it. In some cases we have it, in some cases we don't have it. So can we solve this problem in C? Good question. Of course we can solve this problem in C. So now we have the second program. We will solve one problem here. In the second program, what we do is we solve only one problem. That is, we handle the problem where the name the problem is the length of the name is fixed to 20 characters. So it has two problems. Number one is if the length of the actual name is less than 20 characters, let's say for example 5, then 15 bytes of memory got wasted there. That's number one. The second case is if the length of the name is greater than 20, then we will not be able to store it in our system. So these are the two problems we would like to address using the dynamic memory allocation. So in dynamic memory allocation, so now the data structure that we use to store this array of to store this list of names is what we have on line number 61. That is, we use an array of character pointers. So it's not this is an one dimensional array. So again, remember, max list is still equal to 100. This problem we are not solving. But but each entry here, it's a pointer to a character. That means it's a pointer to a string also. It's a pointer to, so each element, this is here, it is a pointer to a string. So it's the second element here, this is also a pointer to a string. So, but let's say after these are all, so these are all pointers to different names. And after that, no, we don't have any names, then we can make this character pointer equal to null, indicating it's not pointing to any name. And the memory for this string is allocated by using malloc function call. And when we make malloc function call, memory gets allocated from heap. So this string and all the strings that are present here, they will be allocated allocated. For the names array be allocated, where will be the memory for this names array? This is the names array. Where is it allocated? Nice. So the memory for this names array, it is allocated in the stack, but the memory for the strings, we will see how the read names function work now. It will be allocated using malloc call, and this memory comes from the heap. So the structure of the code here is also very simple. You read, this is what we do here. Except for the fact we can use any arbitrary sized name in our program, right? So before we try this, let's see what happens if I use if we so this is the previous program. So let's see, we enter all these names. Okay, And then I'm entering a name whose name is very control shift. See here on control shift. Thank you. And then I'm entering a very big name whose characters, or maybe I'm hoping it is greater than 20 characters. And what will happen? Okay, let's put Balram. See, so now it says stack smashing detected and aborted code dump. So when we are using a string whose length is greater than 20, we got into trouble. No, I think even in we got this problem while reading the names itself. That could. So when we give a name whose length is greater than 20, then we get into trouble. Our system will, no, it will be undefined behavior. All right. Are you all with me here? So now let's go back here and see how the read names function will work. So if you see the read names function, uh, so again, so we are using a current underscore name, temporary buffer into which we read the names. And then what we do is, yeah, so we read a string from the keyboard, and we check and we compute the length of that name using the string length function. And then we use an malloc call, and that malloc call, it will allocates a chunk of memory. If length is equal to 20, for example, then so in this particular case, if length is equal to 20, then what we will be passing to malloc will be 21. So it allocates a consecutive sequence of 21 bytes as memory, and the base address of that will be assigned to the names underscore names the array element. And then we copy the current name which is present, the name that is present in the current underscore name buffer to names underscore. This is 20 plus 1, 21 bytes. That's true. 21 bytes overall. How many of you understood this chunk of code? What we are trying to do? Can you take a few moments and see whether this read names function makes sense to you? Remember, I think Jiawal already discussed the malloc function. What malloc does is, whatever the parameter that we pass, it allocates that much amount of memory from the heap and gives it back to us. And the way it gives it back to us is by returning the base address of the chunk of memory. And the base address, we are storing it in the name, the ith element in the ith element of the names array function. So there is a good question. Aren't we restricting the max name length to 100? Well, it is okay. I mean, like, for example, even if you use, if you are realistic, we can make it equal to 1000 also, but it is not a problem. So because where is the memory for current underscore name allocated? It is allocated on the stack, number one. Number two, earlier it's not a 2D array of names. We are just using one array to copy the name from the keyboard buffer to our program buffer. So the wastage is very, very minimal because 1,000 bytes in computer memory, it's not a big deal. As against if you have a million into 1,000 bytes earlier, because earlier the data structure that we are using earlier is a 2D array, right? So if you are storing million names and the size of each name, if you say as 1000 bytes, then it's million into 1000, no, 1000 million, which is extremely large, 1 billion. As against this, so whether you are reading 1 million names or 10 billion names, the no, all you spend is just 1000 characters. That's all. Line 17 allocates 21 bytes. Yes, yes. Line 17 allocates 21 bytes of memory from the heap, and the base address of it will be given to names I. That would be the next part, Lavisha. In the next class, we will see. But are you all with me here in the read underscore names? What is happening here? So if you see, I want you to see this picture. This is a very, very interesting picture. This is your whole program layout. Remember, so somewhere if you kind of ignore other things, so you have your data section here, data section, code section, and then there is heap here, and then there is program stack here. So what happens is the memory for names, this the memory for names, no? So names is allocated memory in the stack. So it is an array. So if you see, this is an array in the present in the stack. And what is happening here is, as you iterate through this loop, you kind of allocate a chunk of memory to store one particular name, and you make this point to the base address of this location. And then again, you allocate, when you make one more call to malloc, malloc will again allocate a chunk of memory using which you can store one more name. And so the base address of this will be contained in the second corresponding position in the names array. So like this, the whole data structure gets stored. And what is the type of each entry in this array? It's a character pointer. So because of that, you will see that we are passing to this read names function an array, and the type of each element is a character pointer. And the type of each element is a character pointer. Return type of malloc is void star. It is a pointer to some it could be anything. So we have to cast it to a char star. Why are we using string copy? Because we are reading the name in current underscore name. No? This is a buffer, temporary buffer. So we have to copy it into the newly allocated space. malloc is like a scratchpad memory. So we read the name from the keyboard buffer, we store it in the current underscore name. From that, you compute the actual amount of memory required, and then you copy it. And names underscore I, what does names underscore I contains? What does names I contains? What does it contain? It contains the base address of the character array. So that's what string copy requires. So string copy takes the base address of the current underscore name array, this array, and it takes the base address of the array that is, and remember, so somewhere in the stack again, your current underscore name is allocated memory. So what is happening is you read the data into this position, and from here you copy it here. And that's what we are doing on line number 8. Are you with me? Yes, no, maybe. What I will do is I will post the previous code and this code today through email. Okay. I would like you to review this code, and we will continue this discussion from the next class. My hunch is some of you or many of you could have been a bit confused. So I want you to come prepared to the next class by looking at the 2 codes I'm going to send. Yes, malloc assigns memory continuously. That's true. When we ask for 21 bytes, it allocates 21 bytes of memory in a contiguous fashion. Okay, so memory allocation. M means memory. So anyway, I will post this video and yeah, and the code also. If the current name is, if the name is greater than max, then we get into trouble. Yeah. If the name is greater than 1000 bytes, then we get into trouble. It will not give any error. We get into some trouble. Yeah. Of course, we can create memory for structures also. That's what you will be doing in your whole of the data structures course. No, no, you cannot do string copy and then assign length. First, you need to get the chunk of memory. Na? Then only you can do a string copy. Let me stop recording here. So I would say I will